determinant 8 minus lambda minus 6 2 minus 6 7 minus lambda minus 4 2 minus 4 and 3 minus lambda equal to 0. So we will use the formula, direct formula method, that is not without opening this determinant. Directly I am going to use that formula. Therefore equation is lambda cube. Okay, lambda cube minus, you can write, if you don't know the formula, just write sum of diagonal elements into lambda square minus sum of cofactors of diagonal elements. Cofactors of diagonal elements into lambda minus determinant of A equal to 0. This is the formula. So that is, therefore lambda cube minus sum of diagonal elements. Sum of diagonal elements means 8 plus 7, 15 plus 3, 18.
Plus of sum of cofactor था ना?
Yeah. 18 lambda square plus sum of cofactor. So sum of cofactor means you will find cofactor of 8, cofactor of 7, cofactor of 3. Okay, so cofactor of 8 means what you will get, 7 3s are 21 minus
5.
16, that is 5. Then cofactor of 7 will be, leave that column, that row, so it will be 8 3s are 24 minus
20.
4, so 20, and of 3 it is 8 7s are 56
20.
minus 36, yeah, 20. So it is 20 plus 20 plus 5, so 45. So directly you can write 45, or if you want you just write that as one more step. If you are writing, it's okay, no problem. So that is 5 plus, so once you get much practice of that one, you can just write it as completely. So this is minus plus lambda minus determinant of A is, I think, 45. No? Just find the determinant. Is it 45? No, 0.
Yes, ma'am. 0.
0. Determinant of A will be 0 here, because the 0 you will get. Determinant of A is 0. So determinant of A value we are getting the 0. Okay. So that is lambda cube minus, see how easy it is, lambda square plus 45 lambda equal to 0. Now we need to factorize this one. Okay, either you use your calculator, or here this is very simple, because if I take a lambda common here, this is lambda square minus 18 lambda plus 45 equal to 0. So that means lambda will be 0, or lambda square minus 18 lambda plus 45 equal to 0. That means two numbers whose sum is minus 18, product is 45, 15 and 3. Huh? So lambda minus 3 equal to 0. So either you use your calculator, use this one and use calculator and solve. Therefore we are getting, therefore lambda is equal to, one value is 0, one value is 3, and the other value is 15. Okay, so that is the values, distinct values. Okay, therefore 3 distinct values, different values. Okay, distinct values you got. Now if you look at this matrix, what is so speciality about this matrix? Can you see something special here? Look at the row and look at the column. Are they same? First row, first column.
Yes, ma'am.
Second,
Transport.
second row,
Yes, sir.
second column. Third row, third column.
Second
They
row,
are same.
second row.
This is a symmetric matrix. Transpose. If you take the transpose, you will get the same thing. So this is actually a type 2, type 3 type of question. That is, if the matrix is symmetric and you are getting distinct values. Okay, but it doesn't make any difference in the method of solving. So this is, see, the previous one, how much big it was. Now it is so simple. Okay, so here also again, if you are using calculator, here you can write lambda equal to 0, 15 and 3. Okay, so these three distinct values you got. Now find out vector corresponding to. Therefore, let the vector corresponding to, or to find eigenvector corresponding to lambda equal to 0. Okay, so let a minus lambda I into x1, or consider where x1 is the vector corresponding to lambda equal to 0. So that is x1, x2, x3. So that is, now again from our equation number 1, equation number 1 means you need to consider the matrix form of this. Therefore put lambda equal to 0. Therefore from 1 again I am telling you need to consider the matrix form. Their determinant we have written, so it is 8 minus lambda minus 6 2, then minus 6 7 minus lambda and minus 4 2 minus 4 3 minus lambda. Okay, so lambda equal to 0 we will put. So 8 minus lambda you will get it as 0, 8 minus 0, 7 minus 0, 3 minus 0. Okay, so this is 3, and x1 is x1, x2, x3 equal to 0, 0, 0. Therefore now again consider any two equations. So consider the equations. So whenever the roots are distinct, we use Cramer's rule. Okay, note it down somewhere. Whenever the roots are distinct, use Cramer's rule. Okay, or consider any two equations and simplify. So consider equations, say 8x1 minus 6x2 plus 2x3 equal to 0. And second one, if I take minus 6x1 plus 7x2 minus 4x3 equal to 0. Therefore, by Cramer's rule, x1 upon, leave that, take the other two, minus 6, 2, 7, minus 4, minus x2, so tell me x1, x2, x3 how much? 8, 2, minus 6, minus 4, and x3 upon 8 minus 6, minus 6, 7. Therefore x1 by 24 minus 14, 10, minus x2 divided by minus 32 plus 12, 20 equal to x3 by 56 minus 36, 20. Therefore
1, 2, 2.
yeah, if you divide this throughout by 10, you will get as 1, 2, 2. Okay, so or you can give 10, 20, 20, but we prefer this one, 1, 2, 2. So this is first vector. See how simple it is. The previous one we did, so we took so much time. Now this is so easy to do. Now let a minus, or let x2 be the vector corresponding to lambda equal to 3. Okay, so when lambda equal to 3, consider a minus lambda into I into x2 equal to 0, where x2 is equal to x1, x2, x3. Find out, simplify. Therefore lambda equal to 3 means equation number 1 you will be giving 8 minus 3 like that. So it is 5 minus 6 2, then minus 6 7 minus 3 4 minus 4 2 minus 4 and 3 minus 3 0. X2 x1 x2 x3 equal to 0 0 0. So consider again. Therefore, consider any two equations. So you will get x1 by. Do I need to write the equations? Consider, say, 2 and 3. I'll take minus 6 4 minus 6x1 plus 4x2 minus 4x3 equal to 0. Then 2x1 minus 4x2 plus 0x3 equal to 0. Therefore, x1 by Cramer's rule, x1 by 4 minus 4, 4 into 0 0, minus 16 equal to minus x2 divided by plus 24 minus 16. Therefore, x1
Then 2, 1 minus 2.
So you can keep it as, if you want, minus 2 minus 1 plus 2, okay, or 2 1 minus 2, whatever way you write, answer is right. So therefore x2 is equal to 2 1 minus 2. You can write it up and down, the 1 minus 2 2 and 1. So now when lambda equal to 15, what you will get from equation number 1 means 8 minus lambda, you will be subtracting 15 from each. Okay, therefore 8 minus lambda I into x3 equal to 0, where x3 is again x1 x2 x3. Therefore a minus lambda means 8 minus 15 minus 7 minus 6. So from 1 minus 6 2, then minus 6 7 minus 15 minus 8 minus 4 2 minus 4 3 minus 15 minus. Solve this. Tell me the answer.
Four minus two, one.
4 minus 2. I mean, you are telling the last
No,
answer.
last answer, last
Okay,
answer.
okay.
Yes, yes.
4 minus 2, 1. What if you got like that? Order may be here and there, means depends on the equations what you are taking, but the final will be same.
Ma'am, 2 minus 2, 1 है.
2 minus 2, 1. Anyone else? Any other answer? X1 divided by
Ma'am, 2 minus 2, 1.
2 minus 2, 1.
Yes, ma'am. 2
Okay,
minus
who
2, 1.
told first? Please check. Let's see. So x1 by 24 minus plus 16.
Yes, ma'am. 2 minus 2, 1.
Then 28 minus 2. Then 56 minus. So this is 40, 40, 20. So 2 minus 2, 1. Please check who told me first. Okay, so these are the three eigen vectors corresponding to. See, in the previous one and this one, how small this is. We took only 12 minutes, I think, to solve this. Okay, so when you will
मैम ये आगे पीछे रहेगा चलेगा ना
chalega,
जैसे
chalega,
2
chalega.
1 minus
Here and sometimes negative also means if it is 2 minus 2 1 na, sometimes you may get 1 2 2 1 say minus 1 minus 2 2 like that. So there is another concept for this one actually. So there no issue in that if it goes up and down and all, no problem.